How's it going, everyone? Welcome, Euler Gonzalez. That's right. So, let's take a look now at the integrated development or integrated development environment, superpowers, as they like to call. This is a course made by Matt Pocock, where the idea is to get into the essentials of Typescript. So by first exploring how do we get here and understand where all of this comes from a small project at Microsoft, where a lot of software engineers that they have experience working on C sharp, so they now need to is develop products and enhance that and provide support. So doing that in plain JavaScript is quite hard due to the dynamic nature of the language, aka this is not a compiled language when you can see the errors at build times, not at runtime. This is one of the trade-off of using any scripted language. So for rapid prototyping, JavaScript is a great language, right? I also did a small prototype to kind of perceive its different pitch tone. So for example, like the that is frequency converter, right? So you upload an audio here, and then you can listen the different tones, right? But again, it is indeed a very interesting experiment. All right. So for example, if I upload oh my god, what it is? So this one, which is uh, midnight, midnight, midnight city. Sorry, from the M83 group, so you can hear the subtle difference in one pitch or another. And of course, this is more lower pitch than this one. And again, this was a very interesting prototype to build because using a bit of vibe coding and some of the web APIs to actually mount this and using Canvas to actually synchronize that. So yeah, that's very interesting things to do, especially for prototypes, right? But as our application grows in complexity, and then we have a lot of different people working together, and then you need to handle is how all of these different pieces of information go from one place to another. So you need to keep track of that, and when you're writing your code, that must be explicit about what it's doing, the intention of the author code. So again, the TLDR is now with JavaScript and TypeScript. That's the whole point of this. JavaScript prays for prototyping, whereas now once your prototyping gain traction, so you can now shift to a TypeScript code base, right? And since TypeScript have now two scenarios, first is the development, and then is the productions. On the developments, this is when you use now an ID, the integrated development environments, where in our case I'm gonna use this VS Code, that you now let a TypeScript server run behind the scenes on any time that you make a file change in a TypeScript file. You're gonna see that change reflected directly on your ID. And once you're already done, now it is time to generate is the proper JavaScript or evergreen JavaScript code that is now available for all major browsers. And this part is something that is quite complex, especially when you not only have JavaScript files but other different web files, right? So HTML and CSS and then assets like images and the type of image, a PNG, oh my god, WebP and GPEG, and also audio formats like I mentioned before. So A is WWAV or MP3. So for video, this is an MP4 or .avi, right? So it is very complex to handle that scenario. But since we care only on one single type of file, JavaScript, which is the generating is the production output to this. So Typescript now help us here to do so. And then I look at how to do that using the Typescript compiler. How can we set the Typescript config file and playing with common features that at the end of the day, that configuration is grouped in several buckets. So one of them is for determining is a directory output. In other words, let me actually look at that, right? I'm not going to send fruit like in Argentina we like to call. So download docs, and this is the config file. So the config file, project configuration exactly. But let me see if you now that you got it. Project configuration exactly. So what is a config file, right? So whether it's by invoking this, it's going to generate now is, as I mentioned before, is the proper JavaScript files. And this is the common buckets here. You have now file properties. Is this updated? Yes, it is. So you have now file buckets. You also have is the include and exclude bucket. Hey, what are the file or folders directory to be part of this compilation? You also have is the Typescript config basis. That's interesting. Right? But let me take a look at this. If this describe more about this. All right, here we got exactly. So now this is a more detailed description of the config file. So you have is the files, right? Top levels of file extents include, excludes, and reference, and then you have the type check-ins, the modules, all right? The emit bucket. Hey, what do you want me to generate? Is it Typescript configuration? Is the definition files? Is the declaration map, as you can see here, and among others, right? Where I'm going to generate these files, whether it's the dir and out file. What am I going to support? What is the editor support? Interoperability constraint. This is more related to the different JavaScript models or way to wrap functionality, whether it's using CommonJS or ESM, backward compatibility, language environment. For example, in the case of building user interface with React, so hey, I want you to provide me JSX support, for example. Compiler diagnostics, right? Projects and output formatting is completeness and the watch mode, right? So with watch modes, you can spin up a dev server to listen for change and then now throw you on console when something goes wrong, right? An error here. So highlight that. So because this development can be quite monotonous and tedious, especially when you change the file, the Typescript compiler detect that file and then it generate now the proper JavaScript files, but you also need to refresh your browser. So this is why we use now a a front-end development tool called Vite that now, thanks to all the heavy lifting and hard work through the community of the past years, so they have now identified that to speed up this unit is a dev server that take care of reloading the browser, among other additional features, right? So for example, spin up a dev server from scratch, or do a cold boot from a dev server fast, serve the content, at least in development, as fast as possible. So that feedback loop is getting closer and closer and closer. So you can get that. And when it comes now to generate is the production, which is taking all of these assets and be ready for delivery. Now you need is reuse some of these existing tools. So model bundlers like Webpack, or particularly what Vite is using is ESBuild and Rollup for production. This is just a set of library that say, hey, what is the amount of files that I need to generate to be ready for production in terms of HTML, CSS, and image or assets, SVG. Even if you have audio and video, most likely they live in a different server, in a bucket, right? And how now, so doing this, right, making all of your assets ready for production is a very complicated task, right? Because you have to do per file, and considering is the nuance of sending that file and its limitations that particular file might present. So, but in any case, right? So this is why I look at Vite, right? This next generation of front-end tooling, which is the here is help you to now close the gap between is the development. As you can see, all of these different files, right? I would like to see exactly. Let me see if this is that, JSON, Vue, TSX, CSS, GSX, Svelte, SAS. Well, they repeat that. But the idea here is that this is all of the different files, at least for frameworks, that this needs to handle that, right? In order to generate what's the browser understood, HTML, CSS, and JavaScript, right? So, Vite now allows us to spin up a dev server and also come with these integration testing scenarios. Again, this is for most robust applications, but the TLDR is that you at least need to have is the dev server, right? And the test environment. So Vite actually simplify this, because trying to match the conditions of the dev environment and the testing with production is very, very hard. So in any case, I just mentioned this because this is exactly what we use to do so, right? So that's why Vite is being loved by the community, because it's framework agnostic. It's just sit on top of JavaScript, and it reuse some of these model bundlers, right? So whether it's ESBuild for development and for production is using Rollup, and well, there's a lot of people actually pushing the boundaries here, right? That's interesting, because Void Zero is this company brought to you by Void. Oh, Oh, the JavaScript tooling company. Oh, that's interesting. They create mm, mm, that's interesting. The unified tool chain for the web. Okay, good, good. So they make this as a mm-hmm, mm-hmm. Exactly. They have now the build tool for the web, the test runner, right? The bundler, the Blazing Fast JavaScript bundler, and this OX, which is the fast JavaScript language tooling, tool change. So OX is the foundation of our unified tool change. It includes linter, formatter, parser, resolver, transforming, and minifiers, all with the state-of-the-art performance, right? So developing applications here on the current state of the web, right, uh, is something that has grown in complexity, but again, is to solve these industry standards. All right. So now, with that, all right, uh, then I look now at the essentials of TypeScript, which is you can split now this into understanding is the type system of JavaScript, which is the primitive and the objects, and how we look or in this course here, how I look now is at on this essential, right? Oh, there's another convenient things to talk about. Should TypeScript block your dev server? I don't think it should, uh, because if you're doing some rapid prototyping, you don't want to be blocked. You just want to try and fail to see if that uh, thing is going, right? And then some couple script useful for migrations, database migration for Node.js, or when you need to run some TypeScript command, which is the TSX. All right, so for after that is the essential types and notations. Again, looking at the JavaScript types and how you can do those notations. So first by exploring is the how you can write a function, so you can get familiar with this error that TypeScript throw you, and you can pass now optional arguments, default arguments to a functions, the different type of values that you can have in TypeScript that comes from JavaScript. So whether it is a string, number, boolean, symbol, and big int, and the kind of emptiness like undefined and null, right? So null is for objects, undefined is for primitive, okay? And well, how also you can now type annotating objects, all right? And as you do that, how convenient is to have now a single place to put everything in there, right? So as a TypeScript definition file or a single type. So by using is now the type to define this single object or data value where you can consume that later. And how you can now is pass optional parameters to the objects or setting the default parameters in objects as well. This is quite convenient, typing object literals, right? And several ways to do that. And also is exactly defining its optional property in objects. Something that I mentioned about the single source of truth of types and definitions, and add an array of an object, and how you can specify now that whether it's using is the utility function that TypeScript give it to you. In this utility function, you can think like pretty much as the JavaScript the JavaScript functions that come that are built in the language. So for example, JSON and JSON parser, JSON stringified, and here in the array, you can even specify using the utility functions or using is the square bracket. I do personally like to define using is the function type, and we're gonna see that later on how useful is this to uh, generate dynamic types or to generate new types. Similar like function generate a new value, so genetics or this utility function types generate new types. So we're gonna see that later on in this course. But again, on the array and objects in Typescript, how can we do that? And how we can use is the rest parameters in Typescript that at the end of the day is just a single collections, right? And speaking of collections, because now JavaScript see objects and arrays from two different perspectives, right? So if they're static, in the case of objects, it calls this as a dictionary. So you have now a well-fixed defined set of properties where now their value can vary, right? But you know all of the property at build time. And then you have is the records that you don't know the how many properties this object will have, but at least you know is that the key, you know the value key. All right. So this is the nature of the object, and similar on the array. And by object I mean is hash-like objects. And from arrays, you do have is these two nature is whether it's they're static or aka you know the dimension at first, known as tuple, but each one of those elements inside of that fixed length, they can be different types, string, boolean values, or any other object type, okay? And the and the list, all right, which is something that we are quite used to that. So we don't know is the dimension of this array. We know that it will grow, but at least each one of those elements will have the same type, right? This is the two nature. Why this is important? Well, because as you starting to, for example, know how to describe or set tuple annotations with the and how to set a tuple and how to define default values in tuples, as well as optional parameters in tuples, and how you can start to use now the value of any and when not to use the value of any, which can be double source edge, is quite detrimental for understanding what you are going to do about it. And as you explore is, for example, things like function types, which is how you define this annotation as a function, for example, like callback, and how when you do that, you now return, instead of undefined, you return is void, a specific type of Typescript, and trying to do that using now an event handler like this, right? But specifically, I mentioned is the nature of the objects in an array, because as you starting to create or use, for example, is specific JavaScript objects, as the ECMAScript like to call, right? The ECMAScript call this as key collections. Wait a second moment. So for example, index collections like arrays, right? Or key collections like uh, map and sets, as you can see here, weak map and weak set, something that go beyond the scope of today's video. But these key collections, this is the last one? Yes. This is the updated. Okay. But these key collections are useful for specific use cases. So on the set, it is great for defining its unique value. So no matter how many times you add elements to this set, you will always have the unique value. How this uniqueness is determined is by its identity, not by the content of that. AKA, for primitive value, it will work as expected. But for objects, it will not as you might think it will. In other words, it's not by its content, it's by its reference, by its identity. That's a very, very interesting thing to know. Because after you create now, for example, is things like new set here, right? You say, hey, this is a set, this is a set, and then I want to assign this set to a container to hold its value. It's gonna say is unique. All right, and here I'm gonna say is this unique, and if I say unique dot add, right? So if I now add this object, when I do this, I am telling JavaScript to create now an object. So for example, if I say name, in this case is a where, and if I add this again, which is Arthur, right? And if I add another one, right? If I say now John, and if I say this, I say here Margarita. Right, so if I do inspect what this object is all about, all right, and if you think that, hey, if I now add John again, you think, hey, well, that's supposed to work. I should be only see John one time. But it turns out that you're gonna see John is here and here, right? Again, this is because the way how the language work, and especially how this key collections are working behind the scenes. But if you now do that for single or for primitive values, right? So values that cannot be break down, right? Now you're gonna see that this work as expected. There is no John twice. So why am I mentioning this? Because this is quite useful to now define is what are the type of values that we want, or the typing set annotations, which I do find that's quite interesting. Typing set annotations. And the other is using now map, and how now map here behave now like a it is an index collection. But here you now have a key and a value, right? So the key can be any type, and the value can be as well as any type. And in this case, we just only say, hey, this is the user map. So I just want to assign a number here to map all of these different users, right? And then something interesting when it comes to debugging JSON parsing and type fetching API. Again, this is now looking at first the things that the JavaScript language provide, right? So in this case is the on the structured data, right? Things that now the JavaScript give us to us. So structured data like array buffer objects. All right, I am not quite familiar to this. I'll admit A read modify write modification function is a mathematical function that is represented as an abstract closure that takes two lists of byte values as argument and return a list of byte values. This abstract closure satisfies all the following properties. They perform all their algorithm step atomically. Their individual algorithm steps are not observable. The array buffer, but again, it is describing as this. Use the read modify write modification function internal data structure. My question is that why would I even want to use this? That's a good question. Array buffer or share array buffer objects or data view objects, data view with a buffer witness record, or the atomic objects, right? Or the JSON object. This is something that I know to say, hey, given this object notation, I want to is transform into a string or parse. So something that I am quite familiar, but not with the atomic objects. Let me ask Claude here a little bit now that we are here. Okay. I do want to be. Hey Claude. Hey Claude. I do wanna know. The use case for array buffer, share array buffer. So array buffer, the atomics, but again, because this is very specific to JavaScript, right? Structured data, array buffers, share array buffers, data view, exactly, array buffer, share array buffer, the array buffer, share array buffer, data view, the atomics object, and the atomics object. Since I know what is the purpose of JSON object, okay, which is parse or stringify a JSON, okay, but I don't know, but I want to make but I wanna truly understand but I want to truly understand the other objects. Let me see if I was clear enough to say something like that. I'm not sure. Oh, you know what? Let me reading and writing files, image, audio, and video, working with network protocol that send binary data, interfacing with WebAssembly, and processing data from hardware sensor or WebLG. For example, when you fetch an image or audio file, you might get an array buffer that contains the raw bit of data. Okay. It is a raw chunk of binary data. Think of it like a fixed site block of memory. Or array buffer. Okay, like a bucket. Data view. If your tool for actually reading and writing a specific type of number into an array buffer. Wait, that data view is your tool for actually reading and writing a specific types of number into an array buffer. Without it, an array buffer is just meaningless bytes. Data view lets you say read byte 0 from 3 as a 32-bit integer. Okay. Or write this floating point number at byte position 10. It is especially useful when you are dealing with binary file format that mix different data types, or when you need to control endianness, byte order. Share array buffer is like an array buffer but can be shared across multiple web workers, and this use case here is in parallel processing. Think in video encoding, image processing, or complex calculation when you want truly multi-threading. And the atomic exists specifically to make shared array buffers safe, where multiple workers can access the same memory. So it is safe to say that array buffer, um, is a raw chunk of binary data that we can work. Okay, a chunk raw binary data that represent something in the real world. So for example, exactly, image, audio, video, okay, or any other data, right? The data view is how do we make sense of this raw chunks of binary data, right? And the share array buffer is how to how to share this chunks of binary data for parallelism, for parallel computing. And then you have atomics that make it exactly, and then you have to make it safe to work with share array buffer. Okay. So array buffer is for working with raw binary data, and data view is how you interpret it or manipulate the data view, and then just share it. You say, oh, now that I know this, I want to do that. I want to process this in parallel. All right. But I want to make it sure that parallelism is and then I want to make sure that parallelism works appropriately. Okay, holy moly. Okay, one small addition, besides data view, you can also use type arrays to interpret the array buffer. The difference is type arrays are great when you're working with an array of one type, like this whole buffer is 32-bit floats. And data view is better when you have a mixed type in the same buffer, like byte 03 are an integer, byte 47 are float. Okay, so type arrays for a specific static data type. All right, but data view is when your array buffer has multiple. Okay, represents multiple things, or have a mix types. Okay, okay, okay. This is not a JavaScript course. This is definitely not a JavaScript code, but it makes a lot of sense with when this is structured data. Most of the time, um, in our programming, we're going to managing is different type of data, but so far so good because uh, this array buffer, which is something that we can use to process raw binary data, all right, is a raw binary container, okay, that I can now interact or manipulate this using data view as long as they are mixed type, or I can define a fixed buckets here or a fixed type arrays, right? That I can now is processing parallel using by sharing that across different worker instance, and to manage that concurrency via the parallelism, I use now atomic here. Okay. Again, this is an effort to make JavaScript a multi-processing programming language. Holy fuck! All right, that speaks volume. That's definitely speaks volume. All right, that definitely speaks volume, bitch. Holy moly. Jesus fucking Christ. um, okay, all right. Um, okay, yeah, yeah, yeah. Holy hell. Mm, mm, mm. Oh my God, that's. Mm. I don't think. I don't care. People should read about this, bro. And then, if you're going to be a JavaScript developer, at least you should have a sense of this. There is no need to describe this 100% accurate with all of this different terminology of that, but it will make a lot of sense when you understand how these machines work, this engine work, because now you can solve clients' problems. Hey, I do have this business. I need to somehow is to do X, Y, and Z. Common use case is on the case of e-commerce. Hey, I do have all of this uh, users, and they are now so I do have all of these products that I sell them in different geographic locations. So I do need to find ways to map that data, okay, and then now ask that data or ask questions to that data, show me relevant information, and so on and so forth. So that's interesting. You know, that's quite interesting. Um, so in any case, so all of this was just to describe is the the most common things that we do with Typescript. One of them is using is for debugging JSON parsing, all right. And what happened when you don't know the value um, beforehand? And this is when you define is the explicit type of this, as long as that Typescript allows you to do that, that function allows you to do that. In the case of JSON parsing, it this, right? Or using now as well, the alias here. And the other is when you need to use now web APIs. So for example, the most common one is the network, which is the fetch, and this is what we do here as expected, right? So all of this is just to understand is the basic or the essential types and notation. And then when you get into or when you need to involve in the ID to get yourself familiar of what these things offer to you, so is to understand first what is these IDs doing behind the scenes. So anytime that you now start a Typescript server in your particularly Visual Studio or ID, in my case is the Visual Studio Code. So when I open the VS Code, it automatically creates the Typescript server as long as you have that extension installed, right? And anytime a file change, the server will detect if there for any errors, and if you find an error, it's going to now show you a red line. You fix that, so again the Typescript checks that, and if there is no errors, so the red line disappear, right? And this process will be repeated over and over and over until you close the VS Code or you stop the Typescript server. So in order to now understand what the Typescript server, for example, allows to explore or introspect variables and declarations here, like things and other things, and so on and so forth. So it is great for introspecting variables and declarations. And this is important to understand because at the end of the day, when you're working with any programming language, it is important to know how to work with variables and statement here. There is a very interesting book that you can look at out there written by Kyle Simpson, a software engineer with over 25 years of experience, where he now made this series of books about the You Don't Know JS series. Is currently the second version. And so in that book is described, let me actually take you there. So here in this book is describing is first thing first is the scope enclosures to understand one of the fundamental part of a program. But first, kind of get a sense of how do we get here in the JavaScript community, all right? By understand who invented the JavaScript programming language, why the name of JavaScript, and now who owns the legal trademark, who oversees the technical implementations, which is the TC39 group, and what this bunch of people that work across different web related industries, some of them for browser vendors and hardware vendors. So they get into a room bi-monthly and they discuss and propose some couple champions or these champions, right, from the community. So they propose now several how do you call it, several proposals, right? So that they have to pass through 5 stages from 0 to 4 and work all the way up to the top until they are being part of the spec. All right, and then now understand that right now we can run JavaScript in any different environments, right? For example, not only in the web, but in servers, light bulbs, and robots. But the only reality that matter is the web. All right. This is why the spec describe and anything that has some unexpected behaviors or any JavaScript engine that needs to support some legacy features, it has a particular appendix to describe that. And this is, so for example, when you look at this, the appendix B, right? Oh my God, wait. the annex be like this, right? So, uh, yeah, you can take a look at that. It's quite interesting in terms of understanding how do we get here and so on and so forth. Uh, but again, uh, also, and when it comes to understand the the different places we can run JavaScript, again, just making a quick recap of the get started is, hey, this is what we need to, how do you call it? This is the environment that we can run JavaScript. The only reality that matters is the web, and because now JavaScript can be run also as part of the other environment like the developer tools on the console. This is not a truly JavaScript environment. It is a friendly JavaScript environment. Why is this? Is because how these environments behave, and they don't behave as the spec describe, right? So do this mismatch, all right? And also because now the JavaScript spec evolves over time, and it is up to those JavaScript engines out there and browser vendors to implement those features. Some of them might take uh, quite a lot of time, while others can stick to that as fast as possible. So, for example, with Safari, Safari has a well, has a very special place in the web community for not being, for taking his time, for taking time to do stuff. Whereas Chrome and other browsers, well, actually are now more aligned to the spec. So because of this, right? In Since you need to run JavaScript using the latest feature because it's convenient for developers, and some browsers may not implement that. This is why we use a thing called polyfills, right? So, and this is also important to understand that how this machine works, the JavaScript works, and that is by understanding is how it analyzes the code and how it generates the code, because this is an scripted language. Now JavaScript behaves right now at 2026 more like a compiler when it analyzes the code rather than an interpreted language. So I mentioned this quick recap, as well as with the use of string and why, and the concerns about if a scripted language is fast enough, because at the end of the day it's analyzing its line after another, but the reality is that it doesn't behave that. But JavaScript here is, it works more like a, as I mentioned, a compiled language. But the concern back in 10 years ago, 15 years ago, is that JavaScript wasn't a fast enough language. So they were a couple of attempts to show that JavaScript in this was a fast language. ASM.js was an attempt, and a successful attempt for Mozilla engineers to show that, hey, JavaScript can now run a Unreal game engine and can run a game back in 2011 and 2013. And this create now a subset of JavaScript that actually target a specific JavaScript directive in to the engine, right? And then years by, then now the spiritual successor comes with the name of WebAssembly, which say, hey, let's going to skip now the parsing phase, create a language that look like an assembly language, right? When you move register from one place to another in order to do some kind of operations, and then now that'll be is the input of this Java or this environments, WebAssembly environment. So now WebAssembly becomes now this universal portable target that you can now convert language programs in different language into WebAssembly. So all of this is just to describe is the history of JavaScript, why this is useful and it is important, and because at the end of the day, here I am evaluating and describing is how useful it is for us to introspect in variables and statements. Okay. So speaking of which, it means that understand now what a program is, particularly in JavaScript, all right? What a program is, how JavaScript see a program, how multiple programs can cooperate each others, and then what are the different type of values that we can have in our programs, what those values represent, what values represents, and where we can now held in our program as a container so we can now move them or access whenever we need to via variables. What a variables represents, like a container, all right, of these values. So you can think of this carry out buckets of things, all right, or like boxes, card boxes, where you can put things inside of that. And anytime that you need something, you say, hey, this card box that I put this identifier, which is the variable name, I know where these things have, right? And this kind of analogies from the real world, from the software, is something that to me has worked very, very well in order to understand why we're doing the thing that we do, right? Why we create this kind of programs and what the programs represent, right? So that's this is a like high level thinking or abstract thinking that this abstraction has real implication in your life. So for example, when you create now a system to look you to let's say a program, a fitness program, a nutrition program, which as you can see, I get the results out of these abstractions, out of these programs, right? And this is the whole point of this, right? So what is the thing that I can get from this program, this set of a statement that I need to do to get something out of this? In my case, is hey, to get this body, to get even this look, and so on and so forth. And I do think that's the beauty of this, the powerful thing of this stuff. I want to make a quick pause here. Something that I dreamed yesterday was that I am here. I am here, and it can be kind of duh. I am here is because of this. I am here because an unbroken change of ancestors survive and pass down that knowledge that becomes now wealth here, right? So by going out into a school and learn all of this kind of stuff, and not only that, I went through kindergarten and preschooler and school and so on and so forth, and also understanding is the things around my environment, and thanks to internet, which is like some sort of alien forms the internet, because you can expose to other realities that you even or you wouldn't do that willingly, or it is so expensive to get exposed to that, right? So for example, travel to China or Middle East, so on and so forth, okay? But the idea is that I am here because now this unbroken chains of ancestors that they figuring out how to survive and pass this knowledge down to the new generation. And I definitely thank them. Oh my god. So in any case, here we are, right? And so this is why I describe about the fundamental of a program. What is a program? The variables, the statements, and how now particularly JavaScript behave more like a compiler language when it analyzes a code, not when it generates that scope or that code. And how now, if we get into the details, just briefly, is that JavaScript at the end of the day, it creates now a scope to determine is how these variables identifiers are going to be resolved, and then how they're going to be assigned these values, right? So if you have now some sort of, it's like you have a bucket, all right? Yeah, that's right. You have now this car box, all right? So now the scope say, hey, this is the size of this container, right? And then you put now some sort of sticker on that, right? Which is like some sort of identifier, right? This is what it is. In this case, you say, hey, this thing that whole value is 1, 2, 3. So this value that is holding here inside of this is numbers. You can think of this, right? I'm gonna call this as this thing, and then on the let other thing, you say, hey, this let other things now is storing is an object with the name Alice here, and I'm gonna call it here other thing, and so on and so forth. Why this is relevant and why I bring this up? Well, because when you want to introspect a variable and a statement, all right, this is useful a lot of the time, and I know this is when people thrive because they don't want to understand this. And they now trying to figuring out what the thing is doing, and they don't read and they don't understand. So first is introspecting variables, what these variables can provide to you, and then now introspecting is the declaration here, which is hover on, for example, function calls. So here it can describe is the argument that is received, the method in this case, the get element by the object in itself of the API that is using, and now the element or the identifier or the variable that it needs to, right? So you can also add some documentations on hovers using its GSX and adding this particular example, which I was, that's interesting. I didn't know that you can add example. That's actually why I'm looking at this stuff to get myself familiar with it, okay? And then using now Typescript, you can is manually triggering is autocomplete features, which is what I'm going to focus in today's video, right? So what is the problem here?
Autocomplete is one of the coolest features of TypeScript. Sometimes
okay. There you go.
I'm really not sure how I ever coded without it. Autocomplete can sometimes be a little bit tricky though. For instance, when you have, let's say, an accept object function here, which basically takes in an object with foo, bar, and baz on it, what I'd like you to do is go into this object here and autocomplete all of the elements there. You should be able to do it without typing in a single character. There is a keystroke you can do that I have just plugged into my brain that lets you just autocomplete all of your possible options on there. Super duper important. Also, another situation where you're going to want to use it is on this add event listener when you're autocompleting based off kind of some possible string members here. So this is really important when you can't remember the exact capitalization of like DOM content loaded or blah, 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 blah. This means that you can actually sort of search through a list of all possible events and just choose the one that you want. It's super duper useful. And you have to get this just tattooed on your brain, this autocomplete keystroke, and I'm not quite going to tell you what it is yet. You can skip to the solution if you really fancy it, but you should maybe just check out some docs or just have a little read around, see if you can find it. Good luck.
Yeah, this manually triggering autocomplete. So why this is useful? For property discovery objects and for string discovery values. So for example, on an event. So in order to trigger that, you depend on that, you do this command I, and you can see the property here, right? Or you can do on top of that string and see all the possible options for that event. Holy moly. The autocomplete is here, right? And you can say, hey, this object expect to have this, right? Is to be bar is now a number 100. The next one is to be bass, right? Is number wait, what? Bar to be number, bass to be boolean, you say false, right? And foo, that's interesting because the autocomplete given me in order, you know? The autocomplete sort is in order, which is great. Say hello, right? And there you got it. Holy moly. Okay, and the same here. You say DOM counting on board, lookout can play, and all of these different options here. Or even in input. So I do want to add an event listen on this. All right. Okay. Good.
Okay, I'm on Mac, so my setup is control space. And when I do a control space on here, I get all of the possible options shown to me. Now, I do also have like a bunch of like code snippets as well for various things, but the stuff that shows at the top that has this little sort of box next to it, these are the object properties. And I can even see as a little readout what type they're supposed to be too. So here we have bar, which is a number, so I'll just go 12. Then of course bar is taken out because it's already been declared. So we've got now baz, which is a boolean, so true, and then foo, so foo ABC, for instance. Beautiful, so autocomplete is working great there. In this context down the bottom, it is exactly the same. So I can just control space here and bam, I've got DOM content loaded available to me. I've got all of this other stuff too. And of course, if I just want the drag ones, then I can just type drag and now I'm into there too. So beautiful, DOM content loaded. I just must do this 1,000 times a day when I'm writing TypeScript code. It's incredibly important to my workflow. And it works great with this. It also works great for situations when you just want to sort of see, like, for instance, you're in this position, you know that there is stuff that could be triggered from autocomplete here, so you give it a go and boom, you've got all of the stuff that you can see from the autocomplete. You've even got these purple boxes here. These represent methods as well. So we've got document.append, for instance. Super duper nice. And just another thing that TypeScript gives you out of the box for helping you code faster.
Well, anyway.
Let's talk about TypeScript's errors. TypeScript sometimes warns you about things which will definitely fail at runtime. Here, const a equals.
Wait a single moment. All right.
Equals null, and we're calling a.toString. This will cause a JavaScript error. This will crash your entire app. Okay, so it shouldn't let you do this. And the error it shows you is a is possibly null. So the errors here are slightly different from, it's not telling you exactly what's wrong. It's kind of giving you an error in the right place and making you think, oh, I probably can't call toString on null. Right, that makes sense. So TypeScript sort of gives you the warnings that you need, but sometimes it talks in a little bit of an obtuse way and expects you to pick up the rest. Not everything, though, that it warns you about is going to fail at runtime. This object...
So it speaks you cryptic, right? It gives you things cryptic and expect you to take it away.
Here it's just an empty object we're declaring with obj, and then we're saying obj.foo equals hello. Now obj.foo equals hello, that's not going to cause an error at runtime. This is perfectly fine behavior. We're going to end up with like an object that sort of looks like const obj2 equals foo hello, and this is perfectly fine. But if you think about it, would you prefer it if TypeScript didn't error this way, or that it did error this way? If it didn't error this way, then it would basically be saying, okay, you can just assign anything you want to any object at any time. And probably over the course of an entire application, this would result in probably quite a few bugs. So if you think about it, TypeScript is just really a rule set that is a bunch of different compromises. Sure, it's kind of erroring here in a situation that it wouldn't fail at runtime, but it's only doing that because it thinks on the whole this will result in you doing some safer coding. So of course the best thing that you can do here is you can say, you can actually give it a type of foo string, and this will make the error go away, but of course we'll look at this situation further down the line. Now it will try to warn you as close to the source of the problem as possible. So here we have a type of myUser, and we're saying const user is my user. My user has a property of name string, and we have given like a type here, or passed a property which is incorrect. It should be name, but in fact it's NME. And so it's saying type NME is not assignable to type myUser. Object literal may only specify known properties, but NME does not exist on type myUser. Did you mean to write name? This is on the other side of the spectrum, where TypeScript is giving us a perfect error for this exact situation, and even a suggestion on what we should write. And so of course the thing to do here is just to autocomplete your way there and say name. Fantastic. But sometimes, and you can see the error is like exactly where it needs to be, which is beautiful. But sometimes TypeScript won't give you an error in the exact spot that you need to. For instance, here we are creating a function type, and this function is a function that returns a string. And here, instead of erroring on the 1, 2, 3, which is the actual error because we're returning a number, not a string, it's giving us an error on the actual function itself. This is because functions, when you compare them together, you have to compare the whole thing, which we will look at later, but it means that you get the error further away than what you expect. Whereas we could restructure this slightly and instead give a return type to this function, and we could just say string here. And now it would give the error closer in. So TypeScript does its best. It really does try to make sure that the red line is exactly where it needs to be, but sometimes because of things that you're doing, it can't quite do that. So this is a good introduction for TypeScript errors.
Exactly, the TypeScript approach to errors. So warnings about things that won't fail, or warning close to source, or even warning close to source, or even not. TypeScript approach to errors, bro. And this is Looking at the 045 basic of errors. 045 0445 basic of error here, because it is the Typescript approach to error. Typescript approach to error. Whether it's by sometimes warns about you things that fall at runtimes, but not everything it warns you about. But not everything it warns you about will fail at runtime. If you like to warn, it will try to warn you as close as the source of the problem, but sometimes that's not always possible here, especially when you pass a type here and you specify this.
Let's talk about TypeScript's errors. TypeScript sometimes warns you about things which will definitely fail at.
Quick renaming VS Code.
Let's look at another really beautiful little thing that you can use in VS Code and lots of other IDEs too, which is rename symbol. Here we have a function called filter users by ID, which takes in an ID of string.
Yes.
Then we filter over these users with user.id equals ID. So we're comparing this user ID and we're getting the right users based on its ID. Except that I'm having to use the phrase ID a lot here. So how would I go about renaming just this, for instance, this function parameter of ID string into user ID, or for instance, ID to filter by? So what I could do is I could do a Command D here. So Command D basically selects everything with that exact text. And
So if I say that, Command D, that's interesting. So Command D, and select everything that matches that, bro. Holy hell. Okay.
There. This isn't common to just TypeScript. This is just a VS Code thing, which I know how to use. And I can say user ID here, except for the fact that I've now changed user.userid as well, which is really annoying. What if there was a more powerful way that you could do this, which would smartly just change the things that are referenced to ID here? Well, you can. If you just right-click on ID here and then say rename symbol, what it does is it just opens up this little panel here. I change to user ID and bam, it's just worked. So user ID are now changed. And I can as well just change this to anything I want to. So user ID to filter by, for instance. I can go just to preview as well, just to get a little preview of what I'm doing. And I can apply it or discard it and bam. Done. It's just a beautiful way to operate, and it also works across files as well. So if you have something you need to refactor, like you're working in a big project, rename symbol, so good, and it means that you can just move a lot faster.
Okay, couple things here, right? Couple things here. Right? Select a multiple text instance and use rename symbol for a smaller rename. Yeah, the TLDR of this is this quick renaming in VS Code. This is the two strategies, two strategies. Whether is so based on this, right? You don't. Okay, no problem. Let me put it here. Right. Right. So there are two strategies here. Whether it is renaming via matching characters, okay, select a multiple text instance, all right, via command Command plus D, all right, in Mac, all right, or selecting now or rename symbol for smaller rename, or rename symbol via F2 in Mac. That is a very powerful stuff, bro. Absolutely. So I can now select multiple text instance or check that symbol and modify that. Silly stuff. silly stuff. But it's part of the idea.
Another really useful property of the TS server is you can use it to understand stuff across files. Here we're going to use something called a go-to definition, and it's so useful for navigating big code bases, and only possible with TypeScript. So here what we can do is, let's say we have a function here. We could just command click, I'm on a Mac, so the command click is going to work for me, on this function, and it takes me to the function definition. You see that? My cursor just went whoop and just went up. And if I command click on here, it's going to take me to the implementations of that function. So if I have my function here to my function, then if I command click up here, then it opens up a little box up here, which is all of the references of that function, and I can skip between them like this. So here's my first one, which is the actual declaration, then this one, then this one. Now this is, pretty nice actually when you're working in like a massive file. So let's say you have a 1,000-line file for some reason and you need to jump between all of the pieces. Command clicking on these things, or even just right clicking and go to definition or go to implementations or references, like this can solve a lot of problems, but it can also work across files, which is amazing.
Exactly.
So on this little demo here, we have import hi there from dummy imports, and we can command click on hi there to instantly go to dummy import. We can command click on this to instantly see all of the places that this is used. So there's one definition here and also a couple of definitions inside this file too. This is amazing for navigating stuff. It also works on global types too. So I can command click on this property key, for instance, and boom, I'm in now the global typings for TypeScript where this is declared. And if I close this, then I just go back to the previous file, it can also take you to very mysterious places like documents up here. Ooh, some scary stuff we've never seen before, but these are the global typings for the DOM as well. So this is great for when you're navigating into, for instance, external libraries. You want to sort of debug some types, but also just for getting around your own code base. So you can either do this by command clicking on the function itself, or by right clicking, go to definition, go to implementations, go to references.
Exactly.
I encourage you to explore all of these possibilities in this menu too. So it's just amazing what you can do with TypeScript.
Yeah, but pretty base. Yeah, I am quite well aware of this, right? I am not strange to this, so that's great. Yeah, I'm not strange to this, by the way. I'm not strange to this. Yeah, I'm not a stranger to this, because it works across different code bases, which is great. Which is great. And also, if you have several instances, it will navigate to, it will show you is all of the different instances, and all of this is possible thanks to the Typescript. Okay. And the other is a fast import in VS Code. Oh, exactly.
Here
By
we've got a setup for a very
clicking.
common problem in TypeScript. Let's say that we've taken this file or taken this piece of code from a different file and we've put it in its own module. Now what we need to do is we need to reference all of these things here that no longer have references. So we need to import them over. But there's a bunch here. So we've got session expiration time in seconds, in minutes, and in hours. And these are all coming from this file down here, dummy import. So they're all exported, they're ready to go, we just need to import them. And we need to do it as fast as possible. So time yourself, make sure that you've ready to go, that you're hydrated. I want you to see if you can find a way to import these variables as fast as possible. There are three possible solutions, although one is very, very slow. Good luck.
Fast import in VS Code. Yeah, the one is cannot find name. So one is to say, hey, add, I can hover here and say removing use declaration. I can do this and add import dummy. Alright, so it's gonna do that one time after the another, or by selecting you say, hey, but all of this, or quick fix. Okay, that's interesting. You want to import all of them, right? Fast import in VS Code. Fast import in VS Code. All F11. Just import helpers. Auto import relative path. Auto import relative path. Or in Typescript. Command plus command point. Use a quick fix. Oh, this is to use a quick fix for all of this. So in other words, if you do this, diggy, and if I say quick fix, okay, quick fix. In quick fix, okay, the hell. Okay, quick fix, fast import in VS Code, which is the solution.
Okay, so the first solution is obviously just to kind of like manually write each of these out, which is no fun really. There must be a way for TypeScript to help us out here. Well, what we can do is we can just, if we go autocomplete on here, we will see that we have all of the possible autocompletes here. And we can even just start typing here, and actually this will be auto-completed and add an import automatically for that thing. So we can automatically do session expiration time and grab it there. Autocompletes here and grab the one in seconds. Although it's really kind of annoying that it does this. It's sort of, if you do it from the middle of the variable here, you notice that it actually kind of screws up the rest of this line here, which is annoying. So if you want to do this in seconds like this, if I just remove that for a demo, then you actually need to take your cursor to the end of the variable, autocomplete there, and then you're ready to go. So bam and bam. So that was pretty fast, but that took quite a lot of effort, even just a lot of keystrokes here. What if there was a way that you could just import everything all at once? Well, on my Mac, you can do command full stop, And that opens up a bunch of refactors here, a bunch of quick fixes. I'm on this session expiration time here, but I think for this one I can actually be anywhere. Oh no, I can't. I have to be on this variable here. And I get add import from dummy import, add const to unresolved variable, add all missing imports. Huh? Let's try that. Bam. All missing imports are now imported. You've got to be careful with this one, because if you have, let's say, this variable in another file, then it like exported from another file, then it might kind of like grab it from there instead. So you want to check what it's done afterwards. But for these, because I know that they're only coming from one spot, it's just beautiful. So add all missing imports is really, really nice. And you should be checking this kind of like these little, if I just open up those errors back again, checking this.
So here, by exploring it with this, right, again, you do this, it opens that, but it's interesting because it only opens me is this, you know? You know what I mean? So at least it doesn't show me all of this, but I can now auto import all of this. So fast import in VS Codes are great. All right. So fast scope in Visual Studio. So using command plus point to look up the menu bar, or the help menu, or how do you call it, quick fix? Yeah, quick fix menu here, right? To actually see these options. It is useful to do so. And then organizing imports in large files.
Okay, let's go for another world record here. We have a handle page function which takes in a page, and we're checking if the page is greater than max page. And we've got max page up here, which is being imported from dummy import 2, but we're also grabbing a bunch of other stuff here. We could of course just delete these manually, but what if we're at the bottom of a 1,000-line file and we want to just prune our imports, make sure that we're not importing anything that we don't need to? Well, there is a way to do it, and it is really, really nice, and it's on a hotkey, and it's beautiful to use. Your job is to try to find it. It's the organize imports command, and just give it a go, see what happens, and I'll see you in the solution.
Organize, okay. Organize, import command, in Typescript, VS Code. Control Shift P and organize import. You have now the Shift Alt O, organize import. So in other words, you say Shift Alt O, Shift Alt O, Shift Alt O, replay, the hell? Oh, and Shift Option. Shift Option. You say Shift Option. Oh. Shift Option O. Organize import. What do I select that? Organize import. Shift Alt O or 7. Shift Alt O. So if I'm here and say Shift Alt O, Shift Alt 0, that's interesting. Shift Alt O, and it showed me is this. The fuck is this? What about the solution here?
Ready for this? We can just go Shift Alt O and bam, all done. What just happened there? Well, if I do something different here, if I go Command Shift P, again I'm on a Mac, and I look for a command, this opens up the command palette in VS Code. What I can do is I can find the organize imports command and I can run that. And you can see too that it has command, sorry, it's not command, it's Shift Alt O, and then that, like if you do that key binding, it will run it for you. Or you can do it from the command line too.
But that's interesting because this actually didn't work. Right? So if I have this piece of code, for example, like this, what is this? Organize import problem. Okay. I close this and say organize import problems, and then I say Shift O. Now in VS Code it works. Exactly. So in VS Code it works. Okay. So organizing import is using Shift Alt O to get rid of unused import and organize them by name. Let me do this thing, right? So if filter, let me say, if default username, right? So then I want to do some console log, right? So console log hello earlier, right? And then if I do this, Shift Alt O, it will organize import. Holy hell, exactly. Get rid of unused import and organize then alphabetically. Alphabetically, which is awesome. It's like, holy hell. Before, you know, before, and then after, right? Holy hell. Holy moly. All right. That's interesting.
Okay, let's go for another world record here. We have a handle page function, which
World record.
Here we have a handle page. Okay, let's go for another world record here.
Let's go for another world record. So All right, let's go for another word record. And quick fix refactoring.
Let's take a look at the quick fixes menu again. Here we have a func here, and this function, it has a random percentage, which is basically taking in it's just sort of calling math.random here, and it's then making it to fixed, and it's sort of creating like a random percentage, which is nice, and then it's logging that percentage. What we want to do is we want to basically take the thing that's being produced by random percentage, this little piece of logic here, and just refactor it into its own function. You might take a look and you might just sort of have a little poke around with the stuff that's available in your quick fix, and you can see that maybe you might end up with something that works. So why don't you try some of these quick fix menu items, like extract to inner function in arrow function, for instance, and just try out what's available, and then we'll see if you found the right solution afterwards. Good luck.
Refactor problem here, this one. So for example, with the refactor problem here, which say, hey, if I now hover into this, right? And then hey, give me some auto completion feature, right? It say, hey, oh, right, some auto completion feature, right? And it say, hey, I got all of this interesting interfaces, okay? Whereas the other is the quick fix, right? What the French do you? And the other is the quick fix. Oh, okay, this is how you can have access to these context menus here. Quick fix and autocomplete. So here you say extract or move. Extract to counts in enclosing scope. Extract to inner function arrow. Extract to function in a model scope, and extract to counts in a model scope. Move to a file. Holy hell. Move to a new file. Surround with async function expression. Try and catch and do more. Do while or more. Holy hell. Using the quick fix, bitch. Using the quick fix, bro. Holy moly. That's a very interesting, this quick fix menu here. You say, hey, I do want to extract to inner function in arrow function, which is this, right? It create now this new function here that you're gonna call is something that you wanna call it. Random percentage. This is random generator, right? And what it does is to extract that into this own particular function. So it evaluates that expression for that. Okay, exactly. And now okay. And what it does here is that since this is a computation, let me now extract that into a function. Accessing here to the help quick fix. And in this case, you do things like this. Extract in enclosing scope. Extract to inner function in arrow function. Extract to cons in enclosing scope. Right? That's interesting, but not what I want to. Extract to inner function in arrow function. So inner function in arrow function. Or you say extract to function, it is model scope, which is kind of the same. Or extract to cons into a model code. So it's gonna create now a cons and create now and return that forward. That's interesting. Learn more about JavaScript and Typescript refactoring here. Extract to inner function in arrow function. But the whole point of this is that no code available here. Extracting constants is doing that. Inline extraction function. Again, all of this is to how to get access to this quick fix refactoring. So command plus command plus is a helpful keyboard shortcut to command plus this is a helpful keyword shortcut, right, to access the quick fix menu. All right, and how now that provide you some useful hints to this. So for example, this is only exclusively for that, right? That's a very interesting part of the anatomy of the of my ID here. Holy moly. Okay.
So let's give this a go. Now, it's really important what you target with your quick fix. If you target random percentage here, you're going to get...
Okay. So it is important to target to know what to target, since command plus dot is a helpful keyword shortcut to access the quick fix menu here.
You get some different options. You've got inline variable here. Let's try this out. Well, what that does is instead of using just logging the random percentage here, it actually just removes the name completely and takes this and just inlines it into the console log. Let's try that again. Inline variable, bam, very nice. Notice how fast it did that as well. I just love this stuff. Okay, cool. What if we do, let's say, just grab this little bit here, and again, using command dot, we can say fix using Copilot, explain using Copilot, extract to constant in enclosing scope. Let's try that. Ooh, we got new local. Okay, so random times 100. Let's try that. Beautiful. And we can save, and then prettier will sort of clean everything up. That's really nice. Let's try the opposite of this. Inline it again. I just love playing with this stuff. How about we actually get back to what we're supposed to be doing and taking this whole section, this whole piece of code, and just saying extract to function in module scope. If we extract it to constant in module scope, then it will do this, which is not necessarily what we want. We want it to do extract to function. And now we get extract, we actually get back to what we're supposed to. We can save, and then prettier will sort of clean everything up. That's really nice. Let's try the opposite of this. Inline it again. I just love playing with this stuff. How about we actually get back to what we're supposed to be doing and taking this whole section, this whole piece of code, and just saying extract to function in module scope. If we extract it to constant in module scope, then it will do this, which is not necessarily what we want. We want it to do extract to function. And now we get to name our new function. We can say get random percentage like this. And Now
live
it all just
outside
works
of that
beautifully.
scope
So
of
now we've got a
things.
function we can reuse in different places for get random percentage here. We can even move it to a new file if we want to. These like built-in just quick fixes are so useful, and you
Yeah.
can really do a lot with them that I probably can't even cover in the scope of this chapter.
Autocomplete menu and quick fix menu here. Holy shit.
One of the greatest coding inventions known to man is Prettier. I once bought a formatting JavaScript book when I was just first learning JavaScript because I thought it would be important for me to understand, whether I should use tabs or spaces, how I should properly format a function. Now I don't need to worry about that at all because Prettier just handles it for me. If we look at some code, let's say just this code here, and I add some sort of random spaces inside here, add some more spaces. When I save my file, as you probably will have noticed so far, it just jumps back into the position it's supposed to be. I can just Command Z if I want to. I can also just do a Command S. Whoops, that's not right. Command K and then S in order to save it in this state. But why would you? Prettier can just handle that all for me. So the way this is set up is I have a package.json in this file, and Prettier is installed there. I also have a Prettier VS Code extension installed too. And then I have one more thing which I've got set up, which is inside. I'm going to go Command-Shift-P, and I'm going to go to my user settings, and I have a setting called Format on Save. And what Format on Save does is it formats the file you're doing on save. So a formatter must be available, the file must not be saved after delay, the editor must not be shutting down. So what it means is that every time I save this file, before it commits the save to the file system, it actually just runs Prettier on this file and this file only that's open. It's very, very fast. It means that your code is always looking beautiful and looking very, very clear, and I have no way of knowing how I can possibly code without it. It's just the absolute best thing I can possibly recommend for your IDE. It's not necessarily about TypeScript even. This will work in lots of different languages. Prettier supports just plain JavaScript too, supports lots of other languages, but it's really fundamental to getting a good handle on how to work with TypeScript. And it's something that I don't even think about now. I just press save, formats for me, it's beautiful.
Yeah. And then you have restoring the TypeScript server in VS Code.
We've been talking about the TypeScript server, the TS server that runs in VS Code in glowing terms. It does all of these cool things for you, gives you autocomplete, gives you rename symbol, gives you loads and loads of cool stuff. But sometimes you will need to do something not very nice to it. Sometimes you'll need to reset it. This can happen when configurations change in TS and it's not quite doing what you think it's doing. Sometimes it gets out of sync in funny ways because it doesn't notice that a file changed, for instance, when it's git ignored. And resetting the TS server is always really good to have in your back pocket just in case. So we will look at examples of when we might need to use it later on. So I will just give it to you now as a way that you can do it just at any time. So if you ever think that TypeScript's doing some weird stuff or being maybe a little bit slow, what you can do is you can go Command-Shift-P, and we can go restart TypeScript server. There it is. We can restart the ESLint server if you've got the ESLint thing, but it's TypeScript that we really care about. This will take just a couple of seconds to happen, and then it just kicks into gear again. No fanfare or anything, it just restarts, and then it means that it can sort of relook at your files and make sure the errors you're seeing are correct. So there you go, restarting the TypeScript server. We've been talking about we will look at examples of when we might need to use it later on, so I will just give it to you now as a way that you can do it just at any time. So if you ever think that TypeScript's doing some weird stuff or being maybe a little bit slow, what you can do is you can go Command-Shift-P, and we can go restart TypeScript server. There it is. We can restart the ESLint server if you've got the ESLint thing, but it's TypeScript that we really care about. This will take just a couple of seconds to happen, and then it just kicks into gear again. No fanfare or anything, it just restarts, and then it means that it can sort of relook at your files and make sure the errors you're seeing are correct. So there you go, restarting the TypeScript server.
So that'll be all for this video. Take care. Bye bye.